All right, good evening, everyone. Thank you so much for joining us. My name is Lori Nisbet, and I am a meteorologist for the National Weather Service in Spokane. This is our first of four online training seminars for our spotters or people interested in becoming weather spotters for the Weather Service in Spokane. So we'll get started. This training will last about an hour and a half. So this is a live virtual class. If you guys don't know a lot about GoToWebinar, there's just a couple basic things, which is you don't need your phone to do this. This is all done through your computer and speakers. And then if you have questions, you can hit this questions button and ask a question. There are a couple of handouts that you can click on and download onto your computer if you're interested. I believe this is how you would unmute yourself once I give you permission to unmute yourself. There are poll questions that will pop up that you can answer as we go through the seminar. And I think that's about it. So let's get started. So the objectives of this spotter training class is just to understand the role of what a weather spotter does for the Weather Service and to help you know what accurate information we're looking for when you call and give us a report. And we want you to be aware of severe weather threats for Eastern Washington and North Idaho. For example, we're not terribly concerned about hurricanes, but we are concerned about winds or snowmounts, things like that. We want you to be able to properly know what qualifies as a severe thunderstorm and just the basic structure of thunderstorm developments, and then learn how to prepare you and your family during potential severe weather, and just learn some general good information about the Weather Service and what we do. So first, let's take a look back at what happened last year. Surprisingly, last year we did not issue a lot of severe as far as thunderstorm warnings go in the summertime, but we still had some active weather. The first one being the wind and dust on May 27th. That was mainly across parts of the Columbia Basin, which does include this dust report from Othello, where we did get an observer that had a 52-mile-an-hour sustained with gusts up to 62 miles an hour. So, and then following that, on the 28th and 29th, there was more wind damage and dust across parts of the region. Coeur d'Alene had some trees go down. Again, more blowing dust across the central part of Washington, across Ritzville and Okanagan. Now on June 15th, we had a wave move through in the very early morning hours that produced about 1,300 strikes across our region. The blue dots are negative strikes and the red dots are positive strikes. And on the left, you can see by county, it counts how many strikes were in each county. So for example, Spokane had 308 strikes, which was actually the most of any county. And then after that was Pend Oreille and Bonner with about 125 strikes. And with those thunderstorms, we did have severe hail in the Pomeroy area, in Big Creek, which is just kind of east of Kellogg, in Lancaster, as well as in Endicott. So there were some good hail with these storms as they moved through in the early morning hours of June 15th. And then in November, on the 16th and 17th, we had an atmospheric river push directly into Washington, and it provided a lot of heavy rain that we don't normally see this time of year, and it caused flooding on the Similkameen and Okanagan rivers, which do not normally flood in the fall. They normally flood late spring, maybe early summer as we get snow melt. If it gets too hot too quickly and there's a rapid amount of snow melt in the mountains, or rapid amount of snow melt in southern BC that feeds a lot of the rivers in northern Washington. And so this was really quite unprecedented because it doesn't flood in the fall. So let's talk a little bit about the National Weather Service. We are part of the federal government, Department of Commerce to be specific. So it falls under the Department of Commerce, and then underneath the Department of Commerce is NOAA, which is the National Oceanic and Atmospheric Administration. And then under NOAA falls the National Weather Service. And so the National Weather Service is responsible for all watches and warnings across the entire United States. There are 126 offices, and that includes Canada, or not Canada, I'm sorry. That includes the continuous United States, Alaska, Hawaii, Guam, Puerto Rico. We work with local agencies. We do the 7-day forecast. We kind of are behind the scenes. When you see a high wind warning issued or severe thunderstorm warning issued or winter weather watch issued, etc., those are issued from our office. We are the ones who make the decisions and issue that. We also do a lot of decision support and helping our customers make decisions for their businesses and the economy. And we also do a lot of preparedness and education. So our mission is to help protect lives and property. Our vision is to educate you guys to become a weather-ready nation and know how to take the proper actions to mitigate or lessen the impacts of severe weather for our area. So like I said, there's 126 offices. There's good old Spokane, and our forecast is not divided by counties. So you can't just click on Spokane County necessarily and get the whole forecast for Spokane County. We are divided into what we call forecast zones. And so this image here on the bottom right is an image of what our forecast zones look like. And you can see actually this last winter, we split up this Cascade zone into 3 different zones. So now there's the crest of the Cascades in Chelan County, and then kind of like eastern Chelan County here that includes Leavenworth and Lake Wenatchee and parts of Lake Chelan. And then this part up here includes the Methow Valley, and we call it Western Okanagan County. So we are forecast for 2 states, Eastern Washington, North Idaho, that encompasses 21 counties, and elevation ranges from 9,500 feet in the Cascades to about 170 feet in the Columbia River, along the Columbia River. All right. So now we're going to talk a little bit about observations and tools that we use to help us do our forecast. The first thing is our Doppler radar, and this is the image of it here on the upper right. We are lucky our radar is located at our office. Other offices have their radars located sometimes not at the office. They put it where it can get the best data. Sometimes that means putting it on a mountain or a higher hill or something. But for Eastern Washington, North Idaho, it was determined that the best spot was at our office. And so we're lucky that we have that right there. We have this new feature. It's not that new. It's actually been probably about 15 years, but we have this thing called dual pole, and that's this image kind of in the top. And before the radar would send out a pulse, and the radar is usually just mostly listening to receive data back. And with this dual pole, now we can kind of see two-dimensionally into the cloud to see the structure of the water particle. So whether that be rain or hail or snow, we can decipher that by looking at dual pole data to help us determine, oh, that thunderstorm has a lot of hail in it, or no, it's just big raindrops, which helps us in determining severe thunderstorms. The radar produces things like reflectivity down here, like you'll see, with the darker colors meaning a stronger storm with potential hail or bigger raindrops, bigger particles in the cloud, whereas like the lighter blues would be, you know, smaller particles like light rain or drizzle, sometimes even bugs. And then we also get to see the velocity with the radar, so we can see how things are moving inside a storm. So red means it's moving away from the radar. Green means it's moving towards the radar, and that helps us in determining potential rotation in thunderstorms and if we need to keep an eye on any potential funnel clouds or tornadoes. We also release a weather balloon twice a day, every day. Currently, with the latest time change, it is at 4 a.m. and 4 p.m. But in the wintertime, when we go back, when we change time, it's 3 a.m. and 3 p.m. And there are 92 sites across the United States that do upper air. And this is a picture of our radiosonde, and we just, in the last month and a half or so, upgraded to this new software. When I started in the Weather Service, this radiosonde was about the size of a cereal box. And now it is about the size, a little bit bigger than my fist, maybe two of my fists put together at most. So we've really worked at decreasing the size of the radiosonde. And then, so the radiosonde, which is in this picture, is at the bottom of this. So here's the balloon. Then this orange thing is the parachute. And then at the bottom is the radiosonde. And our balloons go actually quite high. They go higher than the highest mountains in the world. They go higher than planes. They actually go way higher than even this image even shows. This image shows about 100 millibars, which is about 53,000 feet. And our balloon actually goes, typically, it goes between like 7 and 10 millibars, which is about 100,000 feet, give or take a little. It's about 32 to 33,000 meters is how high it goes. And it takes about an hour and 45 minutes for it to be released and then pop. And then when it pops, it falls back down to the ground, and we don't follow it anymore because we typically have other things to be focusing on after that balloon is successful. We also have weather satellites. Currently we have GOES 17, but GOES 18 has just recently been launched in March, I believe. And we have 16 different channels that are available. That includes infrared, which measures the temperatures in the cloud, the water vapor, which measures the moisture in the cloud higher in the atmosphere, and then the visible picture, which is kind of what you would see if you were to be in a spaceship or something, or in a high plane looking down on Earth. And with the latest GOES satellites, we are able to receive images every 5 minutes, which is a new and great thing that we can do because it aids in the early detection of thunderstorms or wildfires. So in this bottom left, you can see this is a wildfire that's developed over Southern California, and you can see all the smoke. And in this image in the middle bottom, that is an overshooting cloud, cumulonimbus cloud, indicating a very strong thunderstorm. We also have surface observations and webcams that we use. So the middle one is this is a picture of an ASOS, which stands for Automated Surface Observing Station. And those are located at several airports across the area. Not every airport, but most of the medium to larger airports across the region. So that would include Geiger, Phelps, Coeur d'Alene, Sandpoint, Bonners Ferry, Lewiston, Pullman, Moses Lake, Ephrata, Wenatchee, Chelan, the Methow Valley, Omak, and Colville, I believe is where all of our ASOSs are located. ASOSs or AWOSs. And they're just observing stations at the end of a runway that report temperature and visibility, humidity, cloud tops, current weather, pressure, etc. We also rely on webcams from DOT or businesses, etc. We use that a lot in looking at snow accumulation, if the snow is accumulating on the roads, if it's just accumulating on the sides of the roads or grassy surfaces. We use it looking to see if it's rained. Is the road wet? Is it not wet? We also use lots of observations, and we'll talk about this in a little bit, but there's a lot of these observations on the right are the airports, and there's also citizen weather observing stations. And so a lot of this is just people who have observation, like a weather station set up in their backyard, and then they are able to transmit the data and we can receive it and see it and look at it. There's also different agencies that have other observing stations like the DOT, etc. They have observing stations as well. And we use all that to help us make sure our forecasts are on track, to see what currently is going on, to help us figure out, the forecast for tonight, etc. We also use supercomputers and high resolution models. So this is like an image of some of the computers that help run the weather service and run these high resolution models. So in the lower right is actually what occurred. This was yesterday mornings, I believe. Yesterday mornings, high res stuff. And this was what they were forecasting at 8 o'clock yesterday evening. So it's some of the high resolution models and then their runs from 12 hours ago. So we can see, are they speeding up? Are they slowing down? Are they producing lighter precipitation, heavier precipitation, etc.? And so we can use this to kind of help us in our aviation forecasts, in our public forecasts, in nowcasting and staffing for our office, saying, oh, wow, it looks like the strongest cells will be, through 7 p.m. Well, maybe we need to see if someone can come in and help out for a couple hours in the evening, etc. And then why do we need weather spotters? Well, there's a lot of reasons why we need weather spotters, but one of them is because, here is our Spokane radar here, kind of in the purpley color, and down here is the blue color, that's Pendleton's radar. And then this mauve color is Seattle's radar. So you can see that there is a bit of a gap in radar coverage across parts of central Washington, and even sometimes kind of down in like the southern Idaho panhandle as well. So you guys, in calling or emailing or providing some of the numerous ways you can submit reports, and you doing that kind of gives us ground truth as to what is really occurring, and help us fill in the holes of maybe what the radar is missing. This is especially true in the wintertime, because a lot of times in the winter, the snow or the rain is falling out of clouds that are like 3,000 or 4,000 feet or even less off the ground. And the radar coverage that we have here across parts of central Washington, the radar can only see at about 10 to 15,000 feet above the ground. So if the precipitation is falling at 5,000 feet, the radar isn't going to catch that. So that's why having spotters is very helpful for us. So I'm going to ask you our first poll question. I'm going to launch it here, and Okay, so what is the role of the weather spotter? If you guys could answer that when you have time, I would appreciate it. And I'm going to check for questions really quick, see if anyone has any questions before we go on. Okay. So I'm going to close that. And I don't know if this will show your answers, but it looks like everyone answered. And the correct answer is to provide weather reports of ground truth on severe weather days. Some people answered to be on call 24/7, and that's awesome. But we at the Weather Service understand that you have lives and you're not always home. You might be on vacation, you might be working, you might be out of town, and so you won't always be able to call when you see severe weather, and we totally understand that. So I would say the best answer would be to provide weather reports of ground truth. All right. Thank you, guys. Okay, moving on to the next. No one asked any questions yet, so we're going to move on to the next part. So what's in a spotter report? We want you to tell us who, what, where, when the event began and or ended, estimation of wind speed or hail size, any damage or injury reports that you're aware of. And if you're uncertain, it's okay to call and just tell us you're not certain, but this is what you see. And you can include reports while traveling. And you can also relay secondhand reports or delayed reports like a day or two later. That's quite all right. Sometimes after a severe event, things were so busy in the office that we don't have time to necessarily verify the warnings as they're occurring all the time. And so sometimes a day or two after, we're calling businesses in La Crosse to try and find verification of our report. We might call a gas station or something. But if you know firsthand, you can even call a day or two later, and that's okay. So the easiest way to call is our 800 number, which should be provided for you. And you'll just tell us what you witnessed, where you are, and the time of the event, the time that you saw that occurring. Because that is important in verifying our warnings in lead time. There's other ways to submit reports that are just as easy. You can go on our webpage, and if you scroll down at the bottom, you see all these little grids or whatever, and there's submit a storm report. And you can submit a storm report that way as well, if that's just as easy for you. You can also share your weather data with us via Twitter or Facebook. Those sites are monitored 24/7. And so you can share pictures and reports. And on Twitter, you can hashtag WA weather and Idaho weather, ID weather, and we'll see those as well. You can also tag us in the report, and we'll see that. There's also Mping. I love Mping because, well, I love it. And then there's things I wish that were different. But it was created by the University of Oklahoma and in partnership with NOAA and NASA. And basically, you download the app. If you were just to go to your app store and type Mping, you can download it. And you just submit, it takes your location and you could submit a report. So you can submit that it's raining or that it's snowing or that you have tree damage from winds or hail, and you can report the hail size. So in that regard, it's helpful because it gets ingested into our computer software. And so I can see your Mping with my radar data. And so I find it very helpful. The thing I don't like about it is I can't acknowledge you that I see your report, but I see it. And sometimes like, for example, if you were to report snow, I think the option is snow and or grapple. So, sometimes I wish you could be more specific or maybe even be able to put like a 10-word comment or something. I wish you could do that, but you can't. But I love the app and it is incredibly helpful. And some people have even used it like when traveling. Like if you were to go to Denver and pull up your Mping, and you could submit data in Denver, and it would go to the office in Denver as it would go into their computer system. So you can do it all across the United States. It doesn't have to be specifically in Eastern Washington or North Idaho. And the thing I like is I have literally seen people driving I-90 and Mpinging along the way. So leaving Spokane, getting out towards Cheney, heading towards Sprague, and they've been reporting Mpings as they've moved across I-90, which is helpful. Is it snow changing to rain, changing to rain, snow again, etc. Like that's all useful information for us, and we appreciate if you're interested in setting up the app and using it. We appreciate it. You can also email the office. The email account is monitored 24/7. So you can submit pictures of any damage or weather that's occurring, and we will get back to you when we can. And we may ask if we can, save your pictures or use them in the future as well. So here's an example of a good spotter report on the left. Someone calling our office saying, "Hi, this is Tom Smith. I'm Spokane Stoddard, 25, calling from my house on the South Hill, and there's currently large hail falling. I measured one of the stones, and it's about the size of a quarter. And this began about 30 minutes ago." That's a good report. A bad report would be, "Hey, how's it going? What are you doing tonight? Who's this?" "Well, hey, Steve, I'm a spotter in Okanagan County. There's lightning I see. Oh, I think that was a storm that passed just to my north. Is there going to be another storm? Are they moving into my area? How long is it going to last? Are you guys busy this evening? Is it going to be much worse than this?" Like, that's not a very good report. Just being kind of quick and precise, and you can give us your report and we may ask you additional questions. So you might say, "It's windy," and we'll say, "Well, do you have any reports? Do you have any tree damage or anything?" "No." "Okay." Or you might say, "I have hail," and you'll say, "Okay, well, what's the largest size piece of hail you have?" And you can report that. So you might be calling us and we might ask you more specific questions. Like you might be reporting hail, but we'll ask, "Well, do you have any winds as well?" So we might ask you a couple additional questions when you call in to give a report. Now, keep in mind that we may also call you. We might see a storm moving into your area, and sometimes if we have time, we'll call you and say, "Hey, there's a storm moving right towards you. Would you mind giving us a call back when the storm passes to let us know what happened?" And that kind of just helps us get ground truth as to what's really occurring. So we've done that before. We'll also call you after the storm hits just to see if we can verify any kinds of warnings that we may have issued. So that's another way for us to get ground truth. And the good thing is we can plot you in our computer system, like in this lower image here. We can plot you, and so we'll see if you're in the direct path, and we'll find the spotter that's closest that we think might be impacted and we'll start with calling them to get information or to see if they'll call us back once the storm moves over them or passes them. Emails are important too, so keep us updated on your current email. Sometimes we will send you an email notification the day of or the day before when we think there's going to be like a widespread severe thunderstorm outbreak, just to kind of give you a heads up to like keep your eye on the sky so that you're ready to call us if you need to call us with any weather that you see or that is currently occurring where you are. And then we also send out a quarterly newsletter to you, and we do that via email as well. All right, time for poll question number 2. What is necessary to give in a spotter report? And I will pull that up. Give me a second. Okay. What is necessary to give in a spotter report? Your spotter ID, your location, a report that happened yesterday at 7 p.m., all of the above. And while you guys answer that, I will look to see if there's any more questions. Okay, I'm going to close that. The correct answer was all of the, was all of the above. So your spotter ID is important, but to me, it's more important that you tell me where, you can tell me you're Bonner 39, but then I have to go into a computer system and find out where Bonner 39 is because I don't know where all of our, couple hundred, several hundred, maybe upwards of 1,000 spotters. I don't know where you all live. So including your spotter ID as well as your location. I'm Bonner 39 in Sandpoint or whatever, your location, and you can give us a report of something that happened yesterday, especially if it's going to help us verify any watches or warnings or advisories we had out previously. So all of the above, thank you. And there, again, are no questions. So I am going to continue on with the talk. So now we're going to talk a little bit about thunderstorms. This is a map of the average annual days of thunderstorms across the United States. And you can see the western US has, in the Northeast, New England, typically have the least amount of thunderstorm days a year, with parts of Eastern Washington and North Idaho having anywhere from about 10 to 20, maybe upwards sometimes of upwards of maybe 30 in a good year. So let's talk about thunderstorm ingredients, things you need for a thunderstorm. So there's 3 main ingredients that you need. You need moisture, you need instability, and you need lift. So moisture in our area tends to stream in from the Pacific, but also in the summertime, we get monsoonal moisture that'll move up from Arizona into Central Washington and Eastern Washington and North Idaho. So that's how we usually get our moisture. Lift occurs typically 2 ways, and that would be with a front. A cold front moving through will lift the air, or you will get just, winds coming across the region. And as you encounter a mountain, that air parcel then gets lifted up over the mountain. And then that brings us to instability. So if it's stable, a parcel will get lifted, and eventually it gets so high, if it's stable, it'll get pushed back down. So that would be a stable condition. A neutral condition would be the parcel gets lifted, and when it gets to the top of the mountain, it just stays at that level. And then an unstable atmosphere would be a parcel gets lifted, and that's enough to keep it going and carrying and lifting higher and higher and higher above the mountain, where you could get vertical growth in the thunderstorm and development of a strong shower or thunderstorm. And then there's also rotation here in the bottom right, which is what you would need if you were concerned about funnel clouds or tornadoes. And rotation is just the change in wind direction with height. So let's talk about the stages of a thunderstorm. There's 3 stages. The first is on the left, the towering cumulus stage. And that's where you're getting just an updraft into the thunderstorm cloud, and it's beginning to build and it's beginning to expand and grow, especially above that 32-degree line. And then we're in our mature stage, so we're still getting updrafts, but we're beginning now to get downdrafts as well. So you might start to see wind and hail and rain with that. And in this mature stage, you can see this, there's a lot of circulations going on here. So you have the updraft coming up, and here in the cloud, we're above freezing. So this is all ice up here. And then it gets pushed down, down into the downdraft, and it gets pushed down below the 32-degree line. And so that ice is now melting. And so now we've got like a layer of water around the ice, and more water droplets are joining the particle, and then it gets shoved back up into the thunderstorm above the 32-degree line, and so now it freezes. So that's how you get hail to grow, is it's constantly going up and then down and then up and then down, and every time it goes up and down and up and down, the hailstone is growing bigger and bigger and bigger. And then we have our dissipating stage, where there is no more updraft. The updraft got cut either by the winds or the cooling temperatures, or by the rain. And then it's just the downdraft, and it's just, you're getting the remnants of this thunderstorm dissipating. So here's a picture of what a thunderstorm cloud would look like. So you can see here's the big cumulonimbus, here's the top, the anvil, this is the overshooting cloud top. We kind of saw that in a picture, that satellite picture I showed. This is what you can kind of see from satellite. Down here is the rain and or hail. Here's your wall cloud coming out of the storm. Here's where you would see a tornado, and then this is your flanking line, which is just cumulus development, kind of part of the updraft of the thunderstorm. And then this would be the downdraft here with the rain and hail. So what qualifies as a severe thunderstorm? Well, you need winds of greater than or equal to 58 miles an hour, or hail greater than or equal to 1 inch in diameter, which is the size of a quarter, or we would issue a tornado warning for a tornado. But sometimes we issue a severe thunderstorm warning, and then later a tornado develops from that severe storm. But less than 10% of all thunderstorms are severe. And even though lightning is always dangerous and always accompanies thunderstorms, the amount of lightning does not necessitate or is not a criteria for issuing a severe thunderstorm. So looking quickly at our severe weather climatology just for Eastern Washington and North Idaho. This is just by year. So blue is tornadoes, the red is severe hail, so hail over an inch, and then the orange is the winds of greater than 58 miles an hour. So you can see dating back by year, the biggest impact by far across our area is the winds. Now, the most active years were 2012, 14, and 1997. But also keep in mind that our Doppler radar wasn't installed until 1995. So it wasn't until 1995 right here that we finally could really see into a thunderstorm like we hadn't seen before. So that's perhaps why this data prior isn't as impressive, I guess you could say. So also more climatology by month, what do we typically see? And so for tornadoes, we see tornadoes. Our tornado month typically is usually May. And then our hail and wind month, where we would see severe wind and hail, is typically July. But you can see we can get any of that almost any month. And we can even see winds from storms in January or November as well, and even tornadoes in October. So pretty much any time of the year we can see any of these damaging elements. And then by the time of day, so as you can see, late afternoon and evening is where we get most of our reports. And we're typically less active in the early morning hours, but we can still get reports late at night, 1, 2, 3 o'clock in the morning. We can still see severe criteria reached even in the middle of the night. All right, here we go with poll question number 3. What makes a thunderstorm severe? Winds to 50 miles an hour, hail the size of a quarter, funnel cloud, or frequent lightning? I'm just going to check our questions really quick. Okay, still don't see any questions. And I will close the poll. So the correct answer, oh, hold on. The correct answer is hail the size of a quarter. So you need winds of 58 miles an hour, hail 1 inch or bigger, which is the size of a quarter. Frequent lightning does not necessitate a severe thunderstorm warning, and not all severe thunderstorms have a funnel cloud. So of those criteria, the thing that would make a thunderstorm severe would be the hail the size of a quarter. All right, moving on. So let's talk a little bit more about tornadoes. They're not typical across our area, but we do see them from time to time. It's a violently rotating column of air attached to a thunderstorm and touches the ground. That's the big thing. It has to touch the ground. Typical tornadoes in our area usually are less than 5 minutes. They have a quarter-mile track or less. They can have wind speeds of 80 to 110 miles an hour. And in our area, we mostly see EF0s or EF1s. And that's enhanced Fujita is what that stands for. And so you can see here on the right, enhanced Fujita scale is based off of the wind speed of the tornado. So we typically see zeros and ones, and you can see the average number of tornadoes a year. Washington and Oregon are 2, Idaho being 5. So we don't see very many in our area, but we can see them. They're just not super frequent. So some stats from 1936 to 2016 is we've had about 64 reports of tornadoes. And the time of day that those typically happen is usually between 1 p.m. and 4 p.m. typically. And you can see here, most of them occur in May, but they can range from March through October. And most of them are zeros or ones, but we have had a few 2s and 3s and 2 that were unknown, and then I'm guessing 0 for 4 and 5. But so that's our climatology for tornadoes. So what about funnel clouds and dust devils, where they are different? So let's talk about dust devils. Dust devils, which is these 2 images on the bottom left, those are dust devils. And they start at the ground and extend upward. And you'll see dust devils with completely clear skies, so that it will not be attached to a cloud. Funnel clouds, which are the bottom right, as well as this Pullman one, and they come out of the thunderstorm cloud. They are attached to the storm, and they start to descend towards the ground. But they are considered a funnel cloud because they are not touching the ground. So once that funnel cloud actually touches the ground, then that would be considered a tornado. But until that point, when that little tip touches the ground, it is considered a funnel cloud. And if you don't know and you're in doubt, take a couple pictures and email us, and we'll let you know what we see. We do get emails, probably a couple emails a year of people sending us pictures of, what is this? So feel free to do that. So poll question number 4 is identify this image. Let me launch that for you. Okay. Great job, everyone. It is a funnel cloud. You are correct. Still no questions, so we will move on. So let's talk about strong or damaging winds. Unfortunately for us, winds happen year-round. And if you were to ask me personally what I think the most impactful weather is that we see in our region, I would say winds. Because winds produce things like the January 13th windstorm, where it had rained a lot prior, and then the front came through with 60 to 70 mile an hour winds, and the roots of the trees, the ground was so saturated from the rain that the roots weren't deep enough, and it just pushed the trees over. That's Comstock Park. There's also things like the windstorm that happened in 2015 that produced major power outages across eastern Washington and North Idaho. We also see winds in the spring And this is April 27th across Spokane. That was probably with a springtime. That could have been a springtime thunderstorm, or it could have been just a cold front that went through. But, you know, with winds, we see winds with thunderstorms. We get winds with cold fronts. We care about winds with fire weather. We care about winds with dust. So winds have big implications for our area. So it's something that we deal with honestly year round across our area. And for us to have severe winds, again, that is greater than or equal to 58 miles an hour. But any winds that produce damage, we always want to hear about that. Hail. So I talked about, when I was talking about the stages of a thunderstorm, I was talking about hail formation, but here's another visual of, you know, you can see it going up and down in the storm, down the freezing line, and then merging with these water droplets and then pushed back up and growing. And then eventually the hail gets so big and heavy that the updraft can't support it anymore. And so it falls to the ground. And did you know that hail can fall to the ground at 100 miles an hour? So that's pretty strong. So I would take it seriously. I wouldn't want to be pelted by quarter or even billiard or golf ball. I wouldn't really want to be pelted with that at 100 miles an hour. But here's an example of different hail sizes that you can use. You know, there's the penny, a quarter, a $50, golf ball, pool ball, baseball, softball, CD, DVD. These are all things you can use to help. You can always pull out a ruler and put your hail against a ruler as well and snap pictures and send to us. So hail is a big concern for us, especially for farmers who hail can do a lot of damage to crops before they're harvested. So something that we always keep in mind. Heavy rain is another big concern. So if you ever receive a half an inch of rain in an hour, or an inch or more in 12 hours, or an inch and a half in 24 hours, those are just, they're not hard and steady numbers. Like if it's close enough to that number, you can always call or email us your report. But those are things we want to be aware of. So heavy rain can occur either as a heavy, quick downpour, or it could be a longer period duration of time, like a steady rain. But either way, they do have big impacts. Like, for example, this image here in the upper right of July 2016 in Omak, I'm guessing that was convective. And so it was a heavy amount of rain in a short amount of time, probably near a hill. You can kind of see there's like a hill maybe here. Probably gets a little bit steeper, and so part of that hill gave way probably and caused a bit of a mud or debris flow. But there's also steady rain causes issues as well, where steady rain just weakens the structure of the hill and can cause the same kind of damage. Flooding and flash flooding is also something we're concerned about. So rising waters on rivers or streams and low-lying areas. So like underpasses, even parts of town like Pullman and Moscow that had the flooding in April of 2019. That was just a lot of heavy rain over a fairly short amount of time. And we also see flooding, flash flooding on fires that can produce debris and mud flows as well. This Williams Flat fire, flash flooding occurred while the fire was occurring. So there were people on the fire lines fighting the fire that we had to have pull off the line to protect them from flash flooding and debris flows. All things that we have to keep in mind when we're looking at our forecasts and deciding on to issue or not issue any kinds of watches or warnings. And then there's mud and debris flow as well. So you can see this middle picture is as you're going down towards the TJ Meenock Bridge in Spokane. That was with a heavy shower that moved through, and part of this hill kind of just gave way and all the rock moved into the street. This is a mud flow from thunderstorms. So we're concerned about post-fire floods as well as just mud and debris moving down a steep slope, like, for example, this picture in Kamei. And then there's dust storms that we're concerned about too. So things like a prolonged dry spell mixed with strong winds, mixed with the right time of farming, either it be planting season or harvesting season. So we're kind of right now in planting season mode. So right now we're concerned about blowing dust, but then come late August and September, we'll be concerned again as harvesting starts occurring across the fields as well. And so dust storms produce a sudden reduction in visibility, incredibly dangerous. They're also called haboobs, and it can lead to major problems, mainly with transportation, pileups on roads from people just not being able to see 20 feet in front of them. The best thing to do would be, if you can, take the exit, the closest exit off the interstate, and just get off the interstate. Even pulling off to the side of the road can be dangerous, because if you have your lights on and people can't see, they'll think you're in front of them and moving. And so they'll be like, oh, that's where the road is. And they'll get behind you and they can potentially hit you because they think you're moving, but you're not. You're pulled over to try and wait it out. So honestly, the best thing to do is just to get off the interstate completely. If you can, just take the exit and pull into a gas station or something. And lightning. So if you're close enough to hear thunder, you're close enough to get struck by lightning. And lightning can strike as far away as 10 miles from a thunderstorm. And more than 50% of lightning deaths occur after the storm has passed and they think they're in the clear, and then lightning occurs. So we always say, when thunder roars, go indoors. So it's best to seek shelter inside your house. But you can also seek shelter in a vehicle if needed. Just stay away from doors and windows if you can, and don't use a corded phone if you have one, etc. Okay, well, question number 5. Identify this image. Is it snowmelt, flooding from heavy rain, flooding from a canal break, or flash flooding from a thunderstorm? Okay, I'm going to close that. Okay, that one's kind of tricky. So I would say it is flooding from heavy rain. I'm guessing that heavy rain occurred in this image, and it literally eroded the road and the ground underneath the road. And so the road just literally broke apart and disappeared. And that surprisingly happens more than you probably realize. The other thing to keep in mind too is people so completely underestimate the power of water and the damage that water can do. It only takes a couple of inches of water to knock a person off their feet. And it only takes about, what is it, a foot to 18 inches of fast moving water to lift an SUV. I think it's 18 to 24 inches for an SUV or truck, and I think it's like 12 inches for a car. So it doesn't take a lot of water to do exorbitant amounts of damage and eat away at roads and cause damage. And that's why it's so important to not drive through flooded roadways, because you can't tell sometimes if the road is even there. Like, it may have been completely, like this one, you can tell the road does not exist. But sometimes you literally can't tell that part of the road is even missing because the water is going over the roadway and you can't tell. So please adhere to any signs that you might see to stay away from flooded roadways. We did have a question. It was, do you need official measuring devices to call in with amounts of heavy rain? You do not. You can always buy a rain gauge if you want, but you don't have to. You could just report you could call us and report heavy rain. You can call us and report, storm drains are getting clogged, or, I drove through this intersection and it was flooded, and things like that. So you don't have to have necessarily a rain gauge to call in any report of heavy rain. All right. We are going to move on. Okay, so spotter safety. We of course want you to remain safe when we're doing any kind of reporting to us. So it's imperative that you protect you and your family first, and we would never ask or want you to get in harm's way of taking an observation or anything like that, to call so that you can call us and give us a report. Like, we're okay with you waiting until it's safe to do so. So, we don't want you to drive over flooded roadways or try and cross down power lines. If it's freezing rain, don't go out and try and walk on your sidewalk to get to something. You can wait it out, and that's okay. So some lightning safety tips, just avoid, find indoor shelter if you can, or inside your car is okay as well. Stay away from the doors and windows. Stay away from plugged in items like a TV or computer. If it's not plugged in, like your phone or a tablet, then that's okay. But anything that's plugged into a wall is at risk. Tornado safety, just, if you're in a rural area, you might be able to drive away, but the best thing is just to seek shelter inside a building, or if you're outside in a ditch. And do not try and ride out your tornado in an automobile. So the best place inside your house would be an interior room with no windows. A basement would be better than an upper level of your house. So those are just some quick tips. Flash flooding, don't cross the flooded roadway. We talked about how, the road can be completely eroded and you wouldn't even know it. Avoid low-lying areas because the water is going to drain to the low-lying areas, and 2 feet of water will carry away most vehicles. So keep that in mind if you encounter flooded roadways. And now we have poll question number 6. Where's a safe place to go during a thunderstorm? Under a tree, in a house, in a boat, in a ditch. Okay, I'm going to close that. The correct answer is in a house if you can. If you're outside and you can't get into a secure building, then a ditch is an acceptable place as well. Now, we did have a question of if you're in a third-story building, like if you're in an apartment complex, you're on the third floor, where's the best place to go? Well, if you have an interior room in that apartment, I would go there, like maybe a bathroom without a window. That would be safe. A pantry or something like that. It would, if you lived in like Tornado Alley, I would say become friends with the people on the first floor of your apartment complex, so you can always go to their apartment and be sheltered in a lower level. That's always an option as well. All right, moving on to the next question, or to the next slide. Okay, so there's just different ways to stay informed. And we issue watches, warnings, and advisories. So watches, the ingredients are there to for a situation to occur. So their conditions are favorable, but we're not 100% confident in it. But there could be severe weather or flooding. A warning means we have the ingredients, our confidence is growing, here's what we're expecting, and we'll issue a warning. And that could be, that could be a flash flood warning, it could be a tornado warning, it could be a severe thunderstorm warning. In the wintertime, it could be a winter storm warning. It could be a dust storm warning. So there's lots of different warnings that we could issue. And then an advisory is just kind of like a nuisance, an inconvenience kind of thing. So like in the wintertime, we would issue a snow advisory if we thought there would be like an inch or two of snow maybe for the morning commute on a Monday. Like not the greatest time for 2 inches of snow to fall during a commute time kind of thing. But it's more of just an inconvenience. You might have to leave a couple minutes early kind of thing. So we have short fused warnings and we have long fused warnings. And the short fused warnings, typically you will get an alert for on your phone, or that's what gets scrolled across the TVs. And then the long fused warnings, they typically aren't alerted. They are not alerted on your phone unless we specifically have a reason to think it's necessary, but it would be pretty rare. So here's some ways to stay informed is the Storm Protection Center does a thunderstorm outlook. And most of our thunderstorm outlooks kind of look like this, where we're just in the general thunder. No severe storms are expected, but there could be some thunderstorms out there. And then there's a couple days a year where we maybe get into this marginal, this darker green, where there could be isolated severe storms possible. And then maybe once a season, we might see slight, which would be scattered severe storms. So that's one way to stay informed. Another way is through our website, just going to our webpage, getting information off of our webpage. On this map, you can click on anywhere on this map and get a 7-day forecast. These are called weather stories. So these are just kind of our, main points we want to, let you be aware of, etc. And then local programs right here. This is where you would click if you wanted to get some information about the spotter program itself. So there's also a mobile, we are not allowed to have an app, but we do have a mobile.weather.gov website you can go to, and you can bookmark it and literally make it like an app on your phone. So it looks like this, and you just type in your zip code or your city, and you can come up, you can list a bunch of, cities here of forecasts that you would like. So like for me, I have, Pullman, where my son lives, the Mount Vernon, where my brother lives, the Phoenix area where my parents winter, so I have a bunch of different cities on my app, so I can pull up the forecast really quick to see what's going on. You can also use this app to look at, to read our forecast discussions. You can see our latest watches, warnings, and advisories on that. I believe you can see the radar on that. So this is an easy way to do that if you're interested in it. It's mobile.weather.gov. There's also the wireless emergency alerts, which are through your phone. And that is set to presidential alerts, imminent threat to life and property, which would be us, which would be tsunami warnings, tornado warnings, hurricane warnings, flash flood warnings, dust storm warnings. Those are all things you would get alerts for on your phone from us. And then there's also Amber alerts that your phone is set to. There's also NOAA Weather Radio. We have several transmitters across our area, and it's a continuous operation. And when we send severe thunderstorm warnings out or other severe warnings out, those get sent automatically to our NOAA Weather Radio. And an alert will go off on your radio, and you will hear the warning in real time. It's literally within like a second or two of us issuing the warning. We want you to be able to stay prepared and be prepared for disasters. And this is part of being part of a weather ready nation, is knowing how to prepare for these kind of weather hazards. And part of that is having a disaster kit and a grab and go bag ready to go. And for me, I'm still growing my safety emergency kit. I have a bin in my closet going out my garage door that I can grab if I need to just shove in my car and leave. In there, I also have a book bag. So if I had to leave on foot, I could put some things really quickly in a book bag and just leave on foot if necessary. So all these things are just things we want you to learn about as being part of a weather spotter, and just for you to be aware of. All right. There's other ways to get involved. So you're a weather spotter now, but you can also join CocoRa's, and you can also be a CWAP. So CocoRa's is the Collaborative Rain, Hail, and Snow Network, and you sign up for that, and you would submit daily rainfall or snowfall amounts to us. It doesn't have to be daily, but it is a daily commitment if you choose. And if you're interested, you can just Google CocoRa's and it'll take you to the website. So all you need to do, CocoRa's, is a rain gauge and a ruler to measure snow. And you just submit it every day in the morning, typically. There's also CWAP, Citizen Weather Observing Program, and that's if you have like a weather station set up in your backyard and you can hook it up to our program, I guess, and we can see your observations from your backyard, temperature, winds, etc. So here's the 3 different things. So, the spotter program's event driven, CocoRa's is daily, CWAP is daily, but it's automated from your weather stations. You just set it up once and it works. So these are just kind of different programs that are available. And then, like I said before, if you were on our webpage and hit that local tab, you could pick our spotter resource page, and that's where you would get any information that you would be interested in. And you can always email Robin as well. if you have any questions, or our office email too. Our office email is monitored 24/7. Robin doesn't work 24/7. So final poll question number 7. What's a good way to stay informed? Monitor our webpage, have your cell phone set, watch your local TV station, all of the above. Okay, thank you. You're correct, all of the above. TV stations, they'll scroll the warnings across the screen, and sometimes they'll break in with information as well. You can always go to our website. Our severe thunderstorm warnings would map on that map that I showed you of our webpage. So that would show up there, and you can monitor it on the radio, you can monitor it on the phone, etc. So there's lots of different ways to stay informed about severe weather. So we've got a couple minutes left. Let's quickly go through our seasonal outlook. So far this year, January through March has been kind of a little bit on the warm side, as well as generally a little bit on the dry side. But things have improved a lot this April. It's been cooler this April. We've definitely gotten several different storm systems that move through that have produced, for some areas, quite a bit of precipitation. So that's good. So looking at our mountain snowpack for today in the right, you can see that we're still holding on to near average snow that we would normally see in the mountains for this time of the year. So that's a good thing across our area. And our water supply and a lot of our rivers is looking pretty good. So talking about drought, you can see there's still extreme drought across parts of central Washington, and that does include most of Grant County. And the outlook, which was issued last week, which goes through July 31st, says that the drought will likely persist for eastern Washington, and it will likely develop for the Idaho Panhandle. So we will likely continue our drought conditions. Even if we were to get a normal amount of rain through the summer, which for us in the summertime, we don't normally see a lot of rain. But if we were to get a normal amount of rain for the rest of April and May and June and July and August, we still would be, we might see some improvement in our drought, but I don't think we would necessarily completely mitigate our drought at all. Looking at our fire season outlook, these are issued at the beginning of every month. And for June, they aren't highlighting anything in Washington or North Idaho, but by July, you can see they're starting to highlight the potential above normal wildland fire potential for parts of eastern Washington, mainly the east side of the Cascades. And then our 8 to 14 day outlook, this takes us into May, and it's saying below average temperatures and above average precipitation. And I looked at the May outlook, and the May outlook for temperatures and precipitation is equal chances. They don't really have a good feeling at the time. They didn't really have a good feeling one way or the other. So they were saying equal chances of above normal or below normal temperatures or precipitation. But for at least the first part of May, they're saying below temperatures and above average precipitation. And then looking at our 3-month outlook of June through August, you will see that they're saying above average temperatures for pretty much everywhere in the continuous United States, except for right along the coastline of the West Coast. And then below average precipitation for the Pacific Northwest. So this is our last slide. So the National Weather Service, plus you guys as spotters, helps us save lives and gives us real data to let us know what's going on where sometimes we can't see. And so we appreciate that. We appreciate you and all the help that you provide us. If you have questions, you can always email the office, and you will receive a follow-up email, and you will be registered. You'll be given a spotter ID if you are new to the spotter program, and you will receive a certificate. So I just wanted to thank you guys so much for coming, and I hope you have a great night.